Previously, we've studied a functional interface with a functional method that took one parameter and didn't return a value. It was void, in other words. Here I want to make my own interface that will perform some calculations on two values and return a value from the calculation. Continuing with my Lambda expressions project, I'll create a new interface in the dev.lpa package and call it operation. I'll make it a generic interface, meaning I'll include a type parameter. For this type, I won't include any bounds, so this interface can be used with any type. I'll add a single abstract method called operate that returns t and takes two values also type t, so value 1 and value 2. This means this method takes two arguments of the same type and returns a value also the same type as the values. This interface is a functional interface. It has one single abstract method. I can verify that by adding a functional interface annotation statement above it. You can see the code still compiles, so we know for sure this is a functional interface. I'll be talking more formally about annotations later in the course. I'm using this one now because it's best practice to include it, and it'll also help you verify that what you intended it to be is really what it is. I showed you earlier that this can get confusing if you're extending existing interfaces. This annotation also informs future developers what your intentions were and warns them not to include additional abstract methods which could break code that uses this interface as a target for Lambda expressions. Before I continue, I want to make sure you have an IntelliJ feature toggled on that will help you understand Lambda expressions better. Going to Settings under the File menu, open the Editor node, and under that open the General node and look for Gutter icons. Select that. In the center of the list, you'll see Lambda listed there, and you want to make sure that's checked. You can see that mine was unchecked, so I'll check it now. Notice this is a pink icon with the Greek Lambda symbol in it. I'll show you what this looks like in the editor in just a moment. First, I want to create a public static generic method on my main class. So I want to include t in angle brackets before the return type, also t. I'm calling this calculator. It's got three parameters. The first is an instance of my new interface type, operation. The second and third parameters are the values that will be used in the operation, type t, the generic declared type. Next, I'll set up a local variable of type t called result that's going to get the value that comes back from calling operate on the function instance, passing it value 1 and value 2. I'm going to print that result out and return it from this method. Okay, so what does all this setup do for me? Well, I want to use this calculator method to perform different operations on different types of data. Let's see how it works. I'll scroll up to the end of the main method and put the code in there. Int result equals calculator. I'll pass a Lambda expression with two parameters, and the code will add these together with the plus operator. I'll pass the values 5 and 2. That's one statement, and the first argument is the Lambda expression. This looks a little like the one I used in the first for each method example in the previous video. The difference here, though, is that I've got two parameters, a and b. Notice that I haven't specified a type here anywhere. The expression on the right of the arrow is a plus b. Remember, this is going to map back to the operations method under the covers. How do I know? Well, notice the pink gutter icon next to this statement. If I hover over that, IntelliJ tells me that this Lambda expression overrides a method on operation. Clicking on the icon takes me to that interface's functional method's declaration, operate. This IntelliJ feature will help you identify the inferred method, which will be used in the context of your Lambda expression usage. In this example, I purposely created my own interface, so this information was known to me, but let's go up to the for each method now, above this, and click on that gutter icon. This time you see the consumer interface is opened in the editor and the accept method is displayed. If you're ever in doubt about the parameters needed or what the resulting type should be, this feature can be very helpful. There's a lot more to cover here, but first I want to run this code. You can see the output, result of operation is 7. Now let me start working through some variations to this Lambda expression. First, I'll change a plus b to system.out.println a plus b in parentheses. This change results in a compiler error. If I hover over that, IntelliJ gives me the message, bad return type in Lambda expression, void cannot be converted to integer. Even though it doesn't look like I'm returning a value from this expression, I really am, because the underlying abstract method has declared a return type. I can't have an expression here that doesn't return a value, like I'm trying to do by using println. I'll undo that. I also can't return a result that has a different value type than the parameters. But I haven't defined the types for the parameters, have I? Well, I actually have passed integers as the second and third parameters to the calculator method. The operation interface's type is inferred in this case, not with an int value, because you'll remember generics don't work with primitive values, but with integer, the wrapper class. I can assign it to an int result because of auto unboxing, and the values are auto-boxed before the operation is performed. What happens if I return something other than an int from this expression? I'll include adding a string as the first part of my lambda expression. That results in another error similar to the previous bad return type in lambda expression, string cannot be converted to integer. When I included test in part of the equation there, everything was evaluated as strings, but 5 and 2 are integers, so I can't return a string from my lambda code. Again, I'll undo that. Now let me add a type to my parameters this time. This results in another valid lambda expression. Whether we specify the types or the type is inferred, when you have multiple parameters, you need the parentheses either way. If I try to remove the parentheses now, you see that's an error, so I'll undo that. A couple more things here. First, I'll change integer b to var b. Okay, now this too is an error, and hovering over that, we get cannot mix var and explicitly typed parameters in lambda expressions. If you want to use var to get Java to infer the type, you have to use var for every parameter in the lambda expression parameter list. Let's see what that looks like. Okay, so now the compiler's happy. Let's try performing some other calculations. I'll try division on 2 decimal values. This time I'll call this result 2 and use the var type, which will display a Java hint for us. I'll execute calculator with a lambda expression with the code to divide a by b. I'll pass 10.0 and 2.5 as the other arguments to the method. What I want to point out here is the IntelliJ hint tells me I'm getting a double with a capital D, meaning a double wrapper instance back. And running that, I get result of operation is 4.0. I've used my single calculator method on both integers and doubles, and with different operations, the first addition and the second division. Let's keep going. I'll add another, result 3, again using var. My expression is going to use string methods on a and b. I'm going to concatenate a to b after calling to uppercase on both a and b, and pass 2 strings to the calculator method. You can see from this code that operations aren't restricted to just numbers or even numeric operations. Any operation can be executed by my calculator method on any 2 elements of the same type, as I'm showing you with these strings. I don't have to write a calculator method for every single type I want to support, and I don't have to write every possible operation in my code that I think calculator should support. Instead, the code that gets executed can be anything that can be passed as a lambda, and that's pretty cool. This frees you up to write code once that can be easily extendable, and it frees up client code to have more functionality, which can be customized by lambdas. I will run this code now. I get Ralph Cramden back, all in uppercase as the result. Okay, so you've gotten used to seeing the return keyword when something gets returned from a method. Why is the lambda expression different? First, let me try adding a return in that first call to calculator in that lambda expression. And you can see that gives me errors. You can only use return in a code block inside a set of curly braces, in other words. I'll add those curly braces, keeping the expression on a single line. But this still gives me an error, although this time it's a different error. The problem is I need a semicolon after the return statement before the closing curly brace. All statements in the curly braces must end in a semicolon like any code block. I'll add one. Now I've got a valid lambda expression which has a return statement. I'll take out the return statement and instead just include a local variable and assign it the result of a plus b. Without the return keyword, I get a message that I'm missing a return statement from this expression. When you use curly braces and your method has a return type defined for it, you've got to have a return statement, as you would with any code inside a method declared with a return type. This isn't true though when you don't have the curly braces, because the result is inferred, and in fact, as I showed earlier, if you do include return in a simple lambda, that's also a compiler error. Only use return in a code block when the functional method has a return type. I'm going to revert that lambda back to its simplest form, which is what I started with. That was a quick tour through a few more lambda expression rules. Let me try to summarize these on a couple of slides next. The rules for multiple parameters used in a lambda expression are shown here. Parentheses are always required, but explicit types aren't. If you use an explicit type for one parameter, you must use explicit types for all the parameters. If you use var for one parameter, you must use var for all parameters. You can't mix and match var with explicit types or omit var from one or some of the parameters. This slide shows the two rules for returning values from a lambda expression. When not using curly braces, the return keyword is unnecessary and will throw a compiler error. If you do use a statement block, meaning you use the curly braces, a return statement is required if the function method has a return type. Okay, so in this video I created my own functional interface with multiple parameters, and I covered syntax rules in a lambda expression for multiple parameters and return types. In the next two videos, I'll be covering Java's built-in functional interfaces. See you in the next video.